किसका है?
पड़ोसी का।
चलो, मैडम अभी नहीं आई ना?
Welcome back. Let's continue the afternoon sessions. Our next speaker is Simon Koch Lipumba. He is remote sensing scientist at the European Organization for the Exploitation of Meteorological Satellites, EMUTSAT. He works in the field of scatterometry, maintaining the scientific software used to process data from the current ASCAT instrument. He is also involved in the development of calibration and validation software for Europe's next scatterometer, SCA, scheduled for launch in 2026. In addition to his scientific work, Simon actively promotes open source development within EMUTSAT and is the author of metopdataset.jl, EMUTSAT's first Julia package. So I welcome Simon Koch.
Thank you for the presentation. It's hidden here. It works? Yeah. Is it possible to read the title? Maybe I can zoom in a bit more. Yeah. Okay.
Could you increase the lighting of your?
Yeah, but I think the lighting of my screen is not connected to the projector, is it? I think it's just the projector needing to warm up. Yeah. Okay, but I'll start. Yeah, the talk is named Exploring Metadata with metadataset.jl. But first I just want to give a little bit of background about what is MetHub, what is EUMETSAT, the place I work, and why is this package even needed. So let me start with EUMETSAT. Yeah. So EUMETSAT is a European organization for meteorological satellites. We establish, maintain, and exploit a European system of meteorological satellites. So we have a number of different member states throughout Europe. It's most of the European countries, and they each have representatives, that delegates that kind of come and tell us what our aim should be. And most of these representatives are from the national meteorological services. So we work closely together with the national meteorological services throughout Europe. We also work closely with the European Space Agency, ESA, which is a separate organization, but we have a lot in common with them. And we work closely together with the ECMWF, which is the European Center for Medium Range Weather Forecasting. And then, of course, also with the WMO, which is the World Meteorological Organization. Yeah, one of our further objectives now is also to monitor the global climate. So traditionally, we have been very focused on the aspect of the data for meteorological application and for weather forecast. But we also have an increased focus on the climate aspects. And in reality, when it comes to the data, there's quite a lot of similarities there. But when you talk about delivering this data to users, there's quite some difference because for weather forecasting, it's very important that the data arrives timely. So yeah, you don't want data from yesterday. You want data as soon as it's recorded. Where for climate data, it's more about long-term stability and calibration of the missions. Yeah. So the METOP satellites is a satellite series that flies in low Earth orbit that is operated by us at EUMETSAT. So in that sense, we consider them our satellites. We also operate other satellites, but I will focus on these satellites today. Originally, it's part of the program called EUMETSAT Polar System, EPS. So sometimes when you see data from the satellites or you hear about the satellite program or the data, sometimes the acronym EPS is used instead of METOP. It can be kind of confusing sometimes, as it is with a lot of satellite programs, but it's similar to, there's the Copernicus program, but then there's the Sentinel satellites. And the reason why you have a program is because the program also incorporates other things like the software on ground, the compute infrastructure on ground, the operation centers, funding for ground stations so we can communicate with the satellites. All of that is under the EPS program, but it's only the satellites flying in space that's named METOP. So that's where the distinction comes. So often in daily use, sometimes the terms are used interchangeably, as synonyms, but there's like slight different nuances to it. So the satellite series consists of 3 satellites. The first was launched in 2006 and were operational until 2021, where it was decommissioned. And then we have 2 missions still flying, 2 satellites still flying. And they are in a sun-synchronous low Earth orbit. Let me just go to like a small rendering of the satellite. This is a small picture showing the satellite. So this is one of the satellites, and it's not a small satellite. It's a quite large satellite platform that has a range of different instruments. So these satellites do not just fly one single instrument, but they fly a number of different instruments, each targeting different parts of the Earth system important for meteorology. So let me just, I listed the main instruments here, and I highlighted 2 in black, and that's YARCI and the ASCAT. And the reason I highlighted those 2 instruments is because I'll show examples of the data from these 2 instruments today. I did not have the time to show data from all the different instruments, even though it could be interesting. We need to focus a bit. Personally, I am part of the science team for the scatterometers. So my specialty is really with the scatterometer, the ASCAT instrument. So that's where I know the most, and you can ask me all the difficult questions. When it comes to the other instruments, I have colleagues that knows much more about them. So I mean, I also know a bit, but it's not my specialty. So the YARCI scientific team doing the level 2 processing is also using a bit of Julia inside EUMETSAT, and have also contributed to the package METOP datasets. So I thought it was quite fitting to show some of their data also, both because it's interesting, but also because they have contributed a bit to this package. So more about the package. I started to author this package, both to be used internally at EUMETSAT, but also to be put out and registered publicly so others can use it. And the idea of it is that it's just a package to read some of our products from the MEDOP satellites, which are in a native binary format. So this binary format can be kind of complex to work with. We put out the format specifications as documents, so you can go and open the PDF, you can look at the tables, you can see where the different binary values are supposed to be and how many bits and bytes each field is. But and previously we also put out some IDL tools and some different tools to read this data, but I lacked a more modern interface. So I started to make this package in Julia with the idea of using the common data model API, the interface, which have been done by Alexander Barth, which is also here, such that these products can be opened and viewed and work with kind of similar to the way we work with NetCDF files with NC dataset to abstract like this complexity of these formats away. It should be said we also have data in other, like we depending on which data product you're looking at, we have them in different formats. So this is really just targeting this category of products because it was lacking. Just to talk a bit about the supported format. So actually, these native formats have quite a lot of structure in common between the different satellites, but they are between the different instruments, but they are actually unique for each product. So each product have a different binary layout inside the data records. So I just started with implementing ASCAD because I used it myself, and we use it a lot in our team. And then also the Yasi products because they are used by the Yasi team. But then I've started to also add some of the other products and have gotten most of it, but a few is still missing. I mean, but they will come soon. I mean, we're working a bit on it here and there. Just to list. Maybe one of the good things why this is interesting, a lot of this data is freely available. So a large chunk of these different products are freely available at the EUMETSAT data store, and even more is freely available if you are for non-commercial and non-operational, personal, educational, or research purposes. So there is example. I mean, I know because I work a lot with ASCAD, the ASCAD level 1 product, the low-level ASCAD. If you use it for operational purposes, so you put out a service where you sell some data that are operational, where you process it each day and send out the product, then you have to contact EUMETSAT and arrange for a proper license. But if you use it for research, it's still free. I just wanted to show the data store quickly. So the EUMETSAT data store looks like this. You can go in and there's a lot of products. You can see and select, and there's 170 you can search. There's this advanced search functionality where you can choose a platform and or sensor type. But what I just want to go and do now is I want to have a look at the formats. So as you can see, we have data in quite a lot of different formats, and I did not make a reader for the NetCDF files because there is already a NetCDF reader in the Julia community, so it's not needed to make a new one. But what I did was I made for these EPS native. It's called EPS native here. So these it's like there's 20 different products. It's not all of them that are unique. Sometimes there are different versions of the same product. I can explain a bit at some point, but I mean, we have the operational ones, and then sometimes we go through the whole data set and we reprocess it to make it more homogeneous and make sure that the same version of the process and the same format specification are used throughout the whole time series. And then we store that as data records, but I mean climate records. But mostly we have the interfaces like that. You can access the data. It shows a panel. You can draw a box where you're interested, or you can just search by time, show the results. And there's some products. You can see the overlap. The ASCAD products are distributed in one orbit at the time. You can click download on the little download button. It requires that you have made a profile and logged in, and then you can download and access this data. There's also the possibility to access the data via API. So there is like a command line tool in Python, or a command line tool called UMDAC that is made to do this either via the command line or in Python. That there are some documentation on, but there's also just an API that if you know a little bit about web app APIs, you can program something that sends a request and ask which product are available at a given time, and then you can use the download API to download it together with an authentication token. But it requires a bit of setup. Yeah. So, data available at the data store. So I hope that makes it a bit more interesting that you can actually get the data. Yeah, so I just made some, I took a couple of examples. So I just downloaded some products, unzipped them, placed them in a folder, and have made some small visualizations here. I won't go into like really deep into application. I just wanted to showcase some of the data as it is, and it's mostly due to a time constraint. I mean, mostly due to a time constraint, but also because in my job I actually don't work so much directly on the application. I work a lot on making sure that the observations are there and that they have the correct quality, so that we deliver quality observations over and over again. And then the question of the application is something that handled more outside the organization. It should be said that these examples are also part of the documentation page for MedUp dataset. So most of these examples here I've kind of modified from the documentation page to fit into this Pluto notebook to make it a bit interactive. That said, making the notebook, I figured out that maybe Pluto is not always an ideal way to work with these data sets. I thought it would be nice for this presentation, but normally I don't use this interactive way. Yeah, so first I want to talk about ASCAD, which is the instrument that I'm actually working on, and it's a fixed beam C-band scalerometer with 6 antenna beams. Maybe I just scroll up and show. It's better to show on the. So here you have these 3 arms, and that's actually the ASCAD instrument, like the front end of it. On each side of the arm, here and here, you have a radiating panel, which I know you have an antenna panel. So each arm have 2 antenna panels. So in total, that gives 6 antennas. And the reason why we have 6 antennas is because we want 3 antennas viewing the right side of the satellite and 3 for the left side. So we actually have 2 swaths. These antennas are C-band radars. So it's kind of similar to what was shown in the SAR presentation earlier today, where we get backscatter values back with intensity. But these 3 antennas are, first of all, it's not SAR because it's not, SAR stands for synthetic aperture radar, and we're not able to do the synthetic aperture. This is a side-looking radar. and it's because it's tuned for coverage to like coverage large extents, and also to be able to operate during all the orbit without any data gaps, and not so much focus on resolution. So our resolution in like the primary products we send out from ASCAT is 12.5 kilometers. So it's quite a larger pixel size that we have, grid size that we have compared to the SAR. But I mean, it's also for a different purpose. So the main use of this data is actually, it's once we have the backscatter from 3 different beams, which correspond to 3 different directions for each swath, we are able to retrieve wind vectors. So we can retrieve wind speed and wind direction over the ocean, and over land we can retrieve soil moisture. And these results are then assimilated into to numerical weather models. So whenever you have whenever you look at a weather forecast, it's probably either use a global weather model or it uses a global weather model as a boundary condition. And for that global weather model, that have been assimilated some observation, and that is likely to include ASCAT and YASI and some of the other data shown here. So that's like a big usage is actually that is just assimilated into the models to continuously improve the predictions with observations. Some meteorologists also get the data and look at it directly. The wind vectors and the soil moisture, I won't talk so much about them today, and it's mainly because they're available in that CDF, so they're a bit unrelated to this package. But the backscatter value, the level 1 product, which is more the direct observation of the instrument, that we only put out, or that we put out in the native format. So I'll take that as an example. So maybe I just go down here. So I imported the package made-up datasets. I just did that in the bottom. Because of Pluto, I don't have to do it in the top. But then I'm able to open the path to the file, and then I get this dataset out. And the printing is done by the common data model. So it should look a bit like when you open a NetCDF file with a NC dataset, or if you use SAR datasets, you get the same sort of printing where you can explore what's actually inside the dataset. So we have the dimensions, we have 3 bands. It's because we have each one is images by 3 radars, and then we have 88 across track samples. Actually, that's 41 in one side of the satellite and 41 on the other side. And then we have a number of lines along track samples, and that's just the long track sample corresponds to 1 orbit, which is 1.5 hours. There's a lot of variables here. I mean, so internally we also use to send these products out, and then they are further processed. So they include a lot of auxiliary information needed to do all this further processing. But I have some examples where I just extract the important things. Or not the important things, but the main variables that represent the observations, and not all the flag fields and other things that are attached. Yes, so this is the key. Here I just get the name of the variable that we are actually mostly interested in. That's is the sigma naught trip. I didn't name this. I auto-generated all these names based on the format specifications. So in the package there's like a CSV file included that I took from the format specifications. So that's where the naming and the description comes from. But This actually contains backscatter values, which is equivalent to what we saw with the SAR. I think maybe we have plotted the amplitude there, but this would be the intensity. We don't have any complex phase in this, because with our pixel size, it doesn't make sense to talk about that. Just to read the data, I just have an example here where if you used other of these data sets package, you probably encountered a lot of missing values, which makes them hard to plot. So just for this example, I use NaN values instead of missing values, which makes it a bit easier to work with and to plot. One thing you have to be aware of is if you have encoded flag values, then like this flag field, which actually bit encodes different flags, then it can be converted to float 64 because there's no int NaN values, and then when you try to read which bit corresponds to which, it can get kind of messy. But I mean, it's a bit of a corner case, I would say. So we read the signal not as just as a full array. I just read it up front, and I mean, the values are in decibel. Just for the ones who already work with backscatter. For the ones who haven't, it's numbers. But yeah, you can get this three-dimensional array out just with numbers, and then we can get the latitude out on the longitude, and that's just two-dimensional arrays with the corresponding locations. For the longitude, this example I used GeoMagi to plot it, so therefore I translate the longitude so it goes from minus 180 to plus 180, and not from 0 to 360. But that's just a little detail. The data also contains a usability flag. So, if that's set to 2, it means that the data is bad. If it's 1, it's, I mean, in the case of ASCII, if it's 1, it's usable, and if it's 0, it's good. And so I just check for that to include that in my plotting. But as a general note, actually, for now that it's JuliaEO and for all the people here using Earth observation data, I just want to encourage people to sometimes actually look at the flags in the data. Because actually as data providers, we often include flags in the data to tell you about the data quality. And sometimes there are some data in there that we know are bad. So using these flags can sometimes improve the quality of the science that you do by simply actually taking a look at the flags and making sure that that you're removing data that are not good. So here I made an interactive visualization with VGL-Magi and GeoMagi of the data. And I mean, here you can see the data in the file. It's a backscatter going from roughly, in the forebeam, it's roughly from minus 10 to minus 25. And it's covering a whole orbit. I mean, we have 3 different beams. I just chose one of them to plot. We can also plot the after beam instead. It will look quite similar. But this is one orbit of data. Because it's projected into a 2D map, it looks like this kind of weird wavy motion on the map. But as Anshul showed yesterday with the presentation of on GeoMagi with the globe axis, it is actually just the satellite orbiting the Earth in a circle, projected down. We have 2 swaths here, so one on each side of the satellite, and then the satellite would actually be orbiting here in the middle, in the white part between them. let me just zoom in to show a little bit more. I mean, this is just a scatter plot. Now it's interesting if this is just a scatter plot of the data. I sometimes just do scatter plots of all the observations because it's robust and it kind of always works for me enough. So I just scattered a lot of points here, but what you can see is we have a higher backscatter over land and a slightly lower backscatter over the ocean from the forebeam, and then we see some variations inland. And I mean, these are the things we use to derive the soil moisture and the wind speed. But I won't go too much into detail. What I might be showing, can I zoom out a bit? Let's see. I made some, can you see there's some red observations here? I just colored the bad observations red. So we actually have some bad observations in this. And this because if the water is too calm, we get very little backscatter back to the satellite. Most of the energy is reflected away, and we have a low signal to noise ratio. So we actually don't have so much signal coming back to the satellite corresponding to the noise. And in those cases, we actually flag the data. But there can also be other reasons. I mean, sometimes depending on where you look, if there's like a lot of radio interference, or if we have an orbital maneuver of the satellite or something like that, we also flag the data in those cases. So this is just an initial plot of the ASCAD level 1. We have 3 beams, so you can also visualize it with different colors. So that's what I did here, where I just took the forebeam and mapped it to red, the midbeam mapped it to green, and the afterbeam and mapped it to blue. And then you get a color visualization. We sometimes use these color visualizations for presentations like I do now, but they're actually not so good for analysis and interpretation, because the colors are kind of highly dependent on the viewing direction of the satellite. So it's not an easy way to interpret the data, but it's an example of how you can extract and work with the data in Julia. So that was an example of ASCAD. I mean, I just won't go through all the plotting code, but it's available, and I will put it up on the GitHub repository if you wanna expand it and have a look on how it's done. The second instrument I will talk about, give an example of, is YASI, which is an infrared atmospheric sounding interferometer, and it's a quite different instrument. So ASCAD was a radar. It's an active instrument. It sends out a pulse. It listens for echo. It has its own things. Where YASI is a passive that just it measures the infrared spectrum. So it has like over 8,000 channels where you measure the infrared spectrum, and then using that, you're measuring the infrared radiation from the atmosphere mainly, and because you measure the radiation from the atmosphere at so many different channels, you are able to invert it and say something about what would be the temperature profile and humidity profile and the amount of trace gases that could give this spectrum. So you are able to derive temperature and humidity profiles. That's also where the name sounding comes from. Sounding is often getting these profiles of the atmosphere. So again, we can open the data just by giving the path to made up datasets. It opens it, and you are able to go and explore it. Again, this dataset have even more variables. So I mean, you can get a bit started with it just by going there, but I mean, you have to actually read a bit what the variables are and which to use, because there's a lot. But I have extracted the important ones, which are the spectrum and the location of each observation, and there's also a cloud fraction included. So I just, for this visualization, I have a better visualization that maybe I will show in the end of my talk. But for this visualization here, I just selected 2 points and in the data. So we have, this is actually one scan line as the instrument flies over. No, the satellite, as the instrument flies over, it scans in lines, and this is one scan line. And then it's taken west of France in the ocean, and I've just chosen two different points, a bit of random, one with 100% cloud coverage and one with 0% cloud coverage. And here I plotted the spectrum as a brightness temperature. So I mean, actually in the data it's stored at radiances, but often to work with it and visualize it, it's better to convert it to brightness temperatures. So brightness temperatures is this thing that if it was like a perfect black body, we were looking at just one single black body, the spectrum would just be a flat line at that temperature. But because it's not a black body, it's not even, I mean, we are looking at the integrated radiation for the whole atmosphere, and the atmosphere have different gases, we get these different spectra. But what you can see is that the one with the clouds is much colder because you don't get, I think this is actually a quite high cloud, so you don't get any radiation below the cloud, so you don't see the hot part of the atmosphere, where the black one here is like clear sky, so you see all the way through the atmosphere and also see the lower part, which contribute kind of a lot of warmer radiation. And I mean, here I just, this is a plot I took from our website that actually have labels on some of the spectral lines you can see in the spectra. So we can see that we have some ozone lines, we have some methane, we have some water vapor, we have some CO2. So from this spectrum, you're also able to derive something about the trace gases in the atmosphere and how much ozone there is. Yeah, maybe I can zoom. No, I don't need to zoom on this. So that was the level 1. That's again, it's kind of the direct observation of the radiances the instrument actually sees. The level 2 is Yasi product. It is actually also in the native format, so I thought it would be interesting to show that. And here it's retrieved, so you're retrieving temperature profiles and humidity profiles, and also profiles of trace gases. I won't show all of it because again, there's a bit too many things. But just I selected some single retrieval outside the coast of Africa from one of the files, and what you can see is that here we have retrieved the temperature profile from the spectrum. We have found out what the corresponding temperature profile would be, and the water vapor profile. And you can clearly see here in the temperature profile that we have the tropopause and the stratopause, where the temperature gradient changes. And in the water vapor, you can also see that in the lower atmosphere there's some more structure. I don't know. In the lower atmosphere. So right now it's plotted versus pressure, because that's how it's stored and how it's calculated. But it is possible to retrieve it and like find out the equivalent heights. But I mean, lower pressure is higher up. So that's the level 2. And I mean, these data are freely available and can be used. And now there's also this Julia package to read some of them. I think mainly now the usage is inside EUMETSAT, but since the usage of the Julia package is inside EUMETSAT, the data is already used quite extensively, especially by the meteorological services. But this Julia package is something that we use inside inside EUMETSAT, but now it's also available to you if you want to have a look at some of these data. And there's quite a lot of data available. So now I will stop this notebook. Wait, I open this link, and then I stop this notebook because I want to show another example. I have many interactive examples, but I don't think I have memory enough to run all of them at once. So that's why I'm stopping and starting a little bit here and there. But I put this to run, and then while I do that, I can talk about the latest thing that I have started is called MetupPy, which is actually just a Python wrapper on Metup datasets. So there's quite a large community working on open source software in Python for especially the geostationary satellites data, and also for some of the optical instrument like images. But they're working in Python and in the PyTroll community and have like a Python package called SatPy, but they don't have this so much support for these native formats from Metup. So I've started together with one of my colleagues to make this Python wrapper. So we just tried to make a Python wrapper around Metup dataset, and so far we just did it, and it works quite well. Quite easy. For me, at least, I'm not a Python expert. I just tried it out, and I think it works easy. You can pip install it, and then you can use a package from Python. Under the hood, it's still under installs Julia and set up the environment and stuff. So it's a bit of a large dependency, but my hope is still that maybe in the future that I can include this as an optional dependency to the SatPy package, and thereby bridging the gap between Metup dataset and what they have been doing to kind of unify the efforts a bit more. But this is very much an ongoing thing. So the first thing we've done is just to make the Python wrapper. And then the next thing we will have to do is to make sure it's good, and then figure out how to integrate it well with SatPy. But I'm trying to do a bit of effort to also make this available where some of our users already are. Yeah, so that's MetupPy. Then I have to see. Okay. It's still thingy. So what I wanted to show after is I wanted to show an interactive example showing some of the spectra from the Yasi instrument. So in the documentation page, maybe I also need to zoom in here. I made some examples, quite some examples. It's also where the things shown in the notebook is from. Maybe it helps if I shut down the notebook. And here we have I made an interactive example with the Yasi data together with GL, Mark, and Tyler. So the whole idea is that the one orbit of this Yasi level 1C is actually quite large. It's like 1 gigabyte, and that's like the compressed version when you on when you actually convert the data to floats and scale it and everything, it grows. But because of this package, you can lazily load the part of the spectrum that you want from the file. You don't have to load all of them. So I made this interactive example that hopefully it will run. If it's not, I just have this picture where you kind of have tile on the background and then you have a scatter plot on top showing the cloud fraction. So we can see how much cloud there is, and then we can zoom in and out to see where we have the observations for this orbit, and then click on the individual observations to see their spectrum being displayed in the bottom. So that's kind of a nice thing that is able to do with like all these visualization tools in Julia to like interactively explore the data a way you wouldn't have been able to before. Okay, it's slowly coming here. But in general, I would say that yeah, we have quite some different data. The thing with this low-level data is that it's quite often on the grid of the satellite, and it's like because we try to. It's a bit giving the observations close to how they're made, because that gives some good properties if you want to assimilate it into weather models and you want to know where the observations come from. But there are other derived products that are available sometimes from some of our partner organizations. We also have data from a lot of from other satellites. So we are involved in the Copernicus programs where we operate Sentinel-3 and Sentinel-6, and also process quite a lot of data from them. Also Sentinel-5 coming up, but I think maybe that data is more available through the Copernicus services and not through our user portal. I'm not completely sure. But besides that, we also have the geostationary satellites to show images from. Oop. Patience is my friend. Hopefully, yeah. Now it works. Okay, so now we can see we have a bunch of observations here. They actually comes in groups of 4, but that's how the instrument is made. So it actually have 4 detectors inside the Yasi instrument. So it takes 4 samples at the time. And I plotted the cloud fraction on top here in white, and I made so you can choose one spectra, and then you can choose another. I think maybe in the example in the documentation, it only supports one. Yeah.
Question: is it just me, or is there more of a gap between like the 2 rows of measurements as you go to the side?
Yeah.
Compared to when you go to the center?
Yeah.
Okay, cool. I just want to be sure.
Yeah. There is. I think it. There is more gap between. I don't know. I think it's an artifact of how the instrument is scanning and recording, and actually also these locations here. I don't know exactly how they are, at which height. Maybe it's the location of the surface or the thing, because you're actually looking at a column of air at a diagonal through the atmosphere. So the observations on the side, I mean, if you're analyzing the spectrum, you have to take account that they're actually more angled, where the observations straight under the satellite are in zenith. So there are some differences there. I mean, it's there's so many rich information in this data, and I mean, sometimes there's a lot of it that you don't need, but that's the way the observations are made. I mean, we don't have this many instruments pointing perfectly nadir downwards. It's one instrument that scans, I think. Yeah. So here I just let me say I take one with a cloud. I take one without a cloud. It's actually not so big a difference, but you can see in this case the one with the cloud is slightly colder. So if we take one spectrum here, the green one is near the tropics. Then let's see if we can find a clear one up here. Oop. Okay, maybe that wasn't so good. Clear one here. Clear one here. We can see there's some temperature differences between the two columns of air, right? Because one is shifted slightly down with respect to the others due to simply that it's a warmer column of air, the one place than the other one. I'm not a specialist on the Yasi, so I have some colleagues that could tell you way more about it. I think there was also an example here where you can see that there's some low clouds and some high clouds. Yeah, so I mean both of these observations are cloudy, but there's quite a temperature difference because one of them is like lower clouds and the other one is higher clouds. Yeah, so so this is an example of how you can. It's a visualization of the data, but it's also an example of like how you can interactively visualize it with all these cool packages we have in Julia and combine it to actually explore this quite large data set without having to have like all of the data in memory at once, but just be able to jump between and see how it is and the different. I mean, some part of the spectra you don't see any. You see very little difference. And other parts of the spectrum you see a larger difference, corresponding to where in the atmosphere you're getting the radiation from. So that's. I actually have, if I have time, I have. Let me shut this down. I just wanted to show in the end also a geostationary picture. So I mean we launched 2 years ago. We launched our next generation of geostationary satellites. The data is also out there. It's freely available. There's a lot of different bands, and it gives like a full disk scan every 20 minutes now. So each 20 minutes you can get like a full disk scan of the Earth, and it has. It has quite some here. It has some different channels. So, I mean, the first channels here are visible, but the first 3 roughly corresponds to red, green, and blue. So that's the one I will be plotting in this example, just to show how it will look. Roughly corresponds to red, green, and blue, and they're available in 1 kilometer resolution. But I mean, as you can see, we also have much more wavelengths in the infrared also, which makes it which is quite good to track clouds at night. So also at when we're on the night side, you can also see the clouds and the movement of the clouds. Yeah, let's see if this shows, and otherwise maybe we can just start with the questions. I think maybe there's also a chance that Felix will show it later. Okay, no, but let's just start with the questions, and then when they come up, I will show you an example of the geostationary images. Oh.
Thank you. Thanks for this great talk. I have a rather basic question from somebody not using SAR data. So I know that when you work in optics, it's quite challenged to get many bands. So especially hyperspectral satellites that just can cover a wide range. But I'm so impressed to see that in SAR, you see when you click on one location on the map, then you get a full spectra, really high resolution spectra.
That's not the SAR. It's hyperspectral infrared. It's the YASI. So it's a different instrument. It's a hyperspectral infrared interferometer. So it works with mirrors and
okay.
So maybe I mix it in, but the ASCAT is a radar instrument on the MEDOP satellite, and then the YASI is an interferometer also on the same satellite. But it's two completely different instruments, tuned completely in different ways.
Okay, okay. And the main use case of this hyperspectral microwave or infrared? Is this for tracers in the atmosphere, or?
So the main use cases is actually to assimilate it in numerical weather models. So I mean, when you look at a weather forecast, if we today look at the weather forecast for Friday, it says something with some quality. But if we look tomorrow, we expect it to be better. And the reason why it's better when we look tomorrow is because between now and tomorrow, we have assimilated a lot of observations from today of what's actually going on in the atmosphere. So we extend our knowledge of what we know. And for this, YASI is quite important. So this hyperspectral infrared, I think it's quite up there in the list of how much skill it improves numerical weather forecasting. And it's basically because it helps correct information about what are the temperature profiles and the humidity profiles throughout the entire atmosphere, and not just a point measurement on ground, but actually gives information about the whole column. I think for the assimilation, they might only currently use the clear sky observations and not the cloudy ones. But I think there is a lot of work on the weather forecasting side to also include what they call all sky assimilation, where they also take the infrared sounder over the cloudy region. Yeah.
Okay, thank you.
But it's also used for trace gases and monitoring of ozone and these other things, atmospheric chemistry.
I want to know if you provide some gridded product where you inpaint the data over the whole globe, or maybe only over the ocean, that can be used in simulations?
So the short answer is no, not right now. So when it comes to observations, we don't have these gridded global observations now. I mean, there's talk about doing something like that because of the whole AI trend and AI things, and the idea is here to maybe resample and reduce the quality of the observation a tiny bit to make it much more accessible. But right now, if you wanted to have these global well-gridded data, what people often do is that they use the ECMWF weather models, the reanalysis data, which actually that actually contains all the satellite observations within, because like the satellite observations are assimilated to correct the model. So that's kind of the combination of satellite observation and model to derive a good gridded product that covers everything and not just the bands that the satellite covers. Oh, yeah. Here I have a picture I found that I thought was pretty of the Earth. This is from our geostationary satellite that we launched 2 years ago, and it provides operational data. Every 20 minutes you can get a picture like this covering the whole globe, and it's freely available. So you can just go get it, and it's at 1 kilometer resolution, So we can zoom in, and then we can see all the different cloud structures and how the clouds are moving around. Yeah, I mean, it's a bit reddish in the colors, but that's because I just did a simple visualization where, I mean, as I said in the start, the 3 bands roughly corresponds to red, green, and blue. And that's why the image looks a bit more red than it's supposed to. But I like than you would expect. But yeah, so this is an example of the geostationary satellite. I mean, we also have a large record of our older generation of geostationary satellites, but this is the newer one that have been for that was launched 2 years ago. And actually, one thing I also wanted to mention. Now I showed the METHOP some data from the METHOP satellites. We actually have just started launching the 2nd generation of METHOP satellites with improved new next generation instrument, and the first was launched in August, but it's still going through calibration and validation, so there's not operational data yet, but soon it will be out, and then we're launching a new one this summer. So the next generation of this type of data I showed is already on its way, and this time they have chosen to put it out in NetCDF from the very start, so it makes it a bit easier from user. This geostationary satellite is also in NetCDF.
How high is this? Sorry, how far from the Earth is this?
How far from the Earth? Oh, I mean, so it's a geostationary orbit. I think it's 3,000 kilometers. Yeah, I can't remember on the top of my head. I should be able to know, but it's very fixed. I mean, you can just Google geostationary orbit, and then it comes out how far it is, because I mean, it needs to fit with the rotation of the Earth. Yeah, 30,000. 35. Okay. Yeah, but yeah, those are also out and available. I mean, yeah, if anyone have use cases, I just showed 3 bands.
Excellent talk. So earlier you showed the color scale representation of the data collected from different imaging geometry, and you mentioned that because they are not directly comparable, this presentation is not directly usable for interpretation. Is there any way to account for those geometry effect to somehow normalize them in some way so that this data from different geometry are more comparable?
Yeah, I mean a bit. So I think with the soil moisture retrieval, I mean the soil moisture retrieval is done in collaboration with us, but it's also done by TU Vienna, the Technical University of Vienna, as part of a collaboration through something we call the ASAF. And I think they derive like a lot of lookup tables to kind of both remove effects of the azimuth direction and also effect of the incidence angle over land to kind of standardize it and derive what they call an equivalent sigma 40, which is like the equivalent. And because that's nice when they try to do the change detection for soil moisture. But so there's ways to account it. But actually, I mean, when we do the wind retrieval, we rely really a lot that it depends on the direction, that there is this directional thing. So I mean, there we just always, when we derive wind direction, we always derive it relative to the line of sight of the mid-beam, and then you correct for the orientation of the satellite afterwards before you send the product out to the users.
Yeah. So it looks like even this differences itself is probably useful information for the speed retrieval.
Yeah, it is. But I still think it's hard to do when you look at it as a visual product. I mean, when you do the analysis and with optimal estimation, it's different.
Okay.
Thank you, Simon, for a wonderful talk. Now we have our next speaker, Felix Kremer. He received his diploma in mathematics from the University of Leipzig in 2014. In 2016, he started his PhD study on time series analysis of hypertemporal Sentinel-1 radar data. He is interested in the use of irregular time series tools on synthetic aperture radar data to derive more robust information from these datasets. He worked on the development of deforestation mapping algorithms and on flood mapping in the Amazon using Sentinel-1 data. He currently works at the Max Planck Institute for Biogeochemistry on the development of Julia data cubes ecosystem in the scope of the NFDI4 Earth project. The Julia Data Cubes organization provides easy-to-use interfaces for the use of multidimensional radar data, raster data. So I would like to welcome Felix Kremer.
Yes, so I'm now going to talk about the on interactively plotting and analyzing large data sets. As we saw in Simon's talk, especially with the new generations, we will have a lot of data that is very large, and we need to handle this some way. And I think Simon, did you use pyramid scheme already in your example? Yes, not yet, but I mean it's on the edge of what is possible with just plotting your data. And the data sets we use, I mean the MetOp data or the geostationary data that Simon showed is 11,000 by 11,000 pixels, and this is rough. It can fit into your RAM, but it won't fit on your screen because your screen will downsample this anyway. And so we can also downsample the data beforehand and then use this downsample data for analyzing and also plotting. So the idea I want to talk about today is so-called pyramids. So what is a pyramid? It's also called overviews in GeoTIFF, for example. So the idea is that we have some high resolution data set, and then we can basically build a pyramid by aggregating the data together. So we go from high resolution to lower resolution to even lower resolution, and by that we, as highlighted here, we basically decrease the size of the data, which then can be used to actually plot it. Because, and then we only need to load or even download the data that we are currently looking at and not the whole data set underneath that might be very large. And so as you see here, we go from very fine scale structure to very coarse structures. And so we developed this package called Pyramid Scheme to then both prepare these data sets to basically downsample your data from high resolution to coarse resolution, but then to also work with the data to plot it, to analyze it. So for computing these pyramids, there's basically two ways. So either you can start with data that is still small enough to fit into your screen. So this is 30 arc-second resolution, so it's a few thousand by a few thousand pixels. So you can just resample that on the fly. Takes you about a minute, and then you're ready to go. And then you can just plot it interactively. Or if you have higher resolution data like 100 meter, 10 meter resolution, you'd like to do this on the disk. So you start with in this example, a ZAR data set, and then you can just build your pyramids on that. You can always choose your resampling function, and also the size of the pyramid, or the size of the coarsest resolution layer. And then this will take some time, especially for very large data sets that might take an hour or a day or so, but that's basically a cost that you pay once. And then you can access the data. So you can currently in Pyramid Scheme, you can access ZAR data that is following this a certain currently emerging standard of how to save these overviews into a ZAR file, or GeoTIFF data, and these are either locally or in the cloud. So you can have your pyramid data somewhere on the cloud, and then you can access it from whichever computer you currently have. And then you can just use Maki to plot this. I'll show an interactive visualization later. But basically, that is then what you have. You have your pyramid object. You just plot it. You say you want a color map. You want a color scale, and then you just get a normal Maki plot. This is currently working mostly with GL Maki. In WebGL Maki, this is still a bit slow, and I'd like to spend the week to also explore whether we could make this a bit better. And then, because these are basically just arrays with other arrays, we can also do lazy computations on them. So the idea is that we have this pyramid, and then we have another pyramid, and then we can just do combinations of this. So here we have the biomass data for 2020 and for 2017, and we want to know where in the world did we have growth in biomass. And so you can do this dot minus, and then you can, and this is basically just pre-registering the computation. And then as soon as you start plotting, this will just do the computation on the fly on the area that you're currently looking at. Because if you would do this on 100-meter resolution, this will take 2 hours or so. But if you do it like this, you would get a plot of your coarse resolution immediately, and then you can zoom into the areas that you're interested in, or that on a high level look interesting because there's something going on. Yeah, and then and now basically what we are currently working on, and what is in the making, is like what Anshul also showed yesterday, was spherical spatial trees of lazy reprojected data. We can combine this with pyramids, so we can have a data set in one projection. We can have another data set in another projection, lazily reproject them on the fly onto the same grid and projection, and then do computations on them. Or in this example, I'm going to show the AGB data that is in lat long, and then we project this on WebMercator so that we can also plot it on Tyler. So I already pre-plotted this. So this is a Tyler map underneath, and then we have a pyramid plot on top of it. And now we can just basically we can zoom wherever we want. This is a bit slow because this is currently pulling both OSM tiles and the data from somewhere on the web on this Wi-Fi connection, which is not that fast. So I think at home that would be a bit faster. So and there might also be some improvements we could be doing beforehand. But then yeah, you can basically zoom into the high resolution, and then this is an example of the Amazon fishbone patterns of deforestations. And no, that was not where I wanted to click. So Yes, as an output, what we are also looking into is pyramids on multiple dimensions, because you might not have the highest resolution in space, but you might have a very high resolution in time. For example, these older generation geostationary data sets, you have still handleable amount of data in space, but then you have it on every 15 minutes, and that for decades. And then basically you won't be able to fit all the data into your plot or into your memory if you would do it for every time step. And so we want to explore how we could do pyramids in multiple dimensions, either making a pyramid for every time step or even thinking about making pyramids in time, of aggregating a long time and extracting the most important features. I'd also wanted to explore other formats that might have overviews, and also integrate Disco Engine for doing more computations. We're currently also working on making this combine nicely with observables, so that you could have sliders in Maki that have some input into your computation, and then this could be done also lazily, and by that opening it up for more use cases. Yeah, and that's it.
Very nice. I guess my question is, so imagine that you have a kind of a large NetCDF data set, right? That's hosted somewhere online. It won't contain the overviews,
Yes.
right? So you need to generate them and save them somewhere. My question is, in that use case, do you need to resave the highest resolution, or can you dispense of it?
I think we could make a way to not have to resave the highest resolution. I think because, I mean, one use case. I think one use case before that is having data that is in overviews, and basically you have a lot of these data sets where you have tiles of geotiffs, but your data is globally, but it comes in 1 by 1 degree tiles, and then what we want to explore at some point is basically, if all of these have overviews, we could stitch together the overviews and then save the coarsest levels of your pyramid somewhere else. And I think also for the NetCDF case, you could basically say we can stitch together all of the NetCDF so that they look like a disk array, like one single disk array, and then basically there's some indexing knowledge somewhere that we know, okay, if you're in this area, this is this NetCDF file. Basically like Kerchunk a bit. Okay. And then we could have a way to know, okay, the pyramid levels are over there. This is currently basically the structure of the pyramid itself as a struct is you have a base level that is a dimensional array, and you have a list of sub-levels that are also dimensional arrays itself. So you can very easily replace whichever level by, it's a convenience that you have in ZAR that you follow this format, and then you can just say pyramid of ZAR file. But you can very easily say, okay, pyramid of highest resolution and all the other levels, which will just be a list of data sets.
Okay, great, thanks.
So what kind of storage overhead does that imply, building the pyramids?
So the theoretical limit is basically 1/3, because you add 1/4 of your data for every So a power of 1/4 for every step of your pyramid, which basically is then at most 1/3 of your data in the spatial case. If you would have the temporal case, if you would only do one dimension, it's I think 1/2 of the data. But yes, that's something to discuss or to think about in the future of how to do these combinations of multiple dimensional pyramids.
I guess I was going to ask about nonlinear combinations of data sets, right? So if you have two high-resolution maps and you want to do, say, the cosine of one times the sine of the other, then the pyramid needs to be rebuilt as soon as you define the combination, right? You cannot do the combination of the pyramids. Is that kind of how do you look at that?
I mean,
if you want to derive, you have two fields. I think you meant earlier you said that you want to add more computational options on manipulating the pyramids and combining them.
Yes.
If that combination is non-linear, right, you cannot do one pyramid and then just combine it. You need to do the non-linear operation first, and then the pyramid.
Yes, this is in nonlinear cases. This would be an approximation of. There's a difference between doing the function and then doing the pyramid versus doing the pyramid and then doing the function. But I mean, yes, that depends very much on the applications you do on top of your pyramid. But I think as a first approximation, you're in a lot of cases still good enough to at least first see something and then maybe wait for the proper computations. Or you could think about zooming into the highest level at certain areas and not that you might be interested in anyway, right? But yes, there's in nonlinear cases, it's not always the case that the computation on your pyramid is the same as doing the pyramid on your computations. That's a trade-off to make, yes.
Yeah, no, I guess, and so that's something that the community has not sort of designed a strategy around to make it as correct as possible in a sense.
Yes, but okay. I think that's always dependent on specific use cases and whether that makes sense to do the computations on a pyramid.
No, totally. I mean, this is not a criticism, this is more of a curiosity question.
Thank you. Now we have our next speaker, Simon Danish. He is a software engineer and open source developer specializing in interactive visualization, GPU computing, and graphics infrastructure. He studied cognitive science at the University of Osnabrück, where his work on machine learning and computer vision led him to discover Julia in 2012. He created Makey.jl, Julia's high-performance visualization ecosystem, and Bonito.jl, a reactive web framework for building interactive applications. With over a decade of full-time Julia development experience, he has contributed extensively to the ecosystem through packages including GPU arrays.jl, file.io.jl, and packagecompiler.jl. I would like to welcome Simon Danish.
Thank you. Let's see. Okay, but I tested this with HDMI and that worked. So it's detected. Yes. Well, that's a good start. Jesus. All right. I'm really happy to be here and talk about Maki and Bonito. And I promise I didn't just want to talk about AI to jump on the hype train, but I think it changes where Maki is going and how I will be working in the future. So I thought it would be interesting to talk a bit about it. I will be talking also about another exciting project I started last year, which is Bonito Book. And I will present some improvements we have done over the last years and talk about Maki 1.0, which is finally very close. And what I'm most excited about is the new ray tracing ecosystem for Maki, which I'm looking forward to. And then I also refreshed some projects from last JuliaEO and will show them. And then a little bit about AI. Bonito Book is a Jupyter alternative, which I got pretty much nerd sniped into because like every month or so I get someone who's like, why is Maki not super well integrated into Pluto or Jupyter? And there's really not that much I can do because yeah, there are some architectural differences which are really hard to overcome. But with Bonito, there was actually already almost everything you need to write your own book, which I then started. And I think there are also some other reasons besides Maki integration. It's the first 100% Julia-based notebook system, which makes it very easily extensible from Julia. It's very easy to write new widgets. It's very easy to change the layout completely. And it's also the reason why I couldn't just change the computer, because this is a Bonito Book presentation. And it's running on like different branches, and it's not that easy to set up yet, but I will polish this in the coming weeks. And I think it's perfect for tutorials, reports, dashboards, and like, yeah, everything that other people love about notebooks. And one unique thing about Bonito Book is that it runs everywhere, and what that means is because of Bonito, it doesn't really care if you put it on a server and therefore serve it as a web page, or if you have it in the VS Code plot pane, or you could actually even have it as a cell output from Jupyter or Pluto, because that's what Bonito was about from the beginning, to have HTML getting inserted into like any kind of HTML viewer. And I just wanted to quickly demonstrate this. Because that also means it very easily integrates with Documenter. So this is actually a Bonito Book, which without me doing anything special already works by default in Documenter. So I used that to write some ray tracing tutorials recently. And there are also some examples showing off a bit like how flexible it is. For example, this is a plugin for Bonito Book, basically turning it into a more scientific book-like format. And I'm actually planning to rewrite Julia and data science with Lazaro to use Bonito Book. So that way you can actually just download an executable of the book, and then you can just interact with everything in the book and basically rewrite it on your own computer. Like the flexibility also really shows, like here, this is still like a Bonito Book, but it's a plugin which basically lets you completely change the layout and how it looks. Yeah, and the slideshow, obviously. But yeah, I think this is kind of cool, and I'm not sure how much of this is possible in other frameworks, but it feels like it's quite a bit harder in other frameworks. Yeah, and as part of some other project, and also for Bonito Book, I actually polished Bonito quite a bit and fixed quite a lot of bugs in the protocol, and like all, it's kind of hard that it's really recursive. You can have like a Bonito Book inside a Bonito Book and observables inside observables. So that was kind of buggy, and now it's, I think I fixed everything. And we are also did a very big refactor of Maki as part of the Sovereign Tech Agency investment, which improved performance a lot, especially for WebGL Maki. So here you can see like the green part is how much we save now with the new version. It's pretty significant, and I think it's a difference of if a project runs in WebGL Maki or not, because we are sending actually a lot less messages because we are moving. We moved to a polling approach, which means now we can skip a lot of computations. Before that, we had to, if you updated anything in a plot, you had to do all the computation involving that, even if you don't render a new frame for that computation. And now it's only polling before actually rendering a new frame. This also cleaned up the backend implementation and fixed a few bugs. For example, multi-updates of attributes, which was previously kind of hard and buggy. And I finally got around to create some loading spinners for WebGL Maki. I think it's on Maki Master now, but not tagged yet. So soon you will see loading spinners if the plot takes a while to load. And this is actually also planned for Bonito apps. So before you had just like a white screen when a Bonito app compiled or took long to load. And now we finally have some spinners there. Yeah, all of this was also on the road to Maki 1.0, like having a more stable WebGL Maki backend. And other things that are missing were complex recipes, which means creating axes and legends and things like that inside a recipe for your own data type, which we now finally have a working PR open. We also have an open PR for automatic color bars and legends, which is it's a really small feature and expected of every plotting library, but in Maki historically we didn't have that because we tried to make everything super flexible and customizable. And that means it got a bit hard to make automatic color bars because then, yeah, how do you work with that if there are already color bars but you don't want them there and want to compose everything nicely? But I think we have now a nice approach for this, and it's also a PR, so all of the 1.0 features are in PRs and are passing tests, most of them. So it's a matter of reviewing them and merging them, which is new because I think the last times I talked about 1.0, it was more in the future. And finally, a lot of people have been asking to in their recipe to be able to set some access attributes, because sometimes, like if you have your own array type, for example, where you have names, you want to set the title of the recipe by default if you're just plotting that array, which is possible now. And a much requested feature was also having some UI elements like saving a plot, copy and pasting a plot, and things like that, which is also up in a PR. So now it's just a matter of merging all of them and releasing it, and then I'm pretty confident to release Maki 1.0 because I don't have many more breaking changes planned. Now for the ray tracing, I've spent a lot of time to implement ray tracing really in Julia. It started with me seeing trace.jl, which looked really nice already. Someone put a lot of work into it. One big problem was that it was really slow and wasn't running on GPUs. And the first thing I did was spending lots of time on it to make it faster and make it run on GPUs. That took quite a while, but made me really optimistic that this is a good approach. This work basically went into RayCore, which is basically a ray triangle intersection engine that you can run on the GPU and on the CPU, and it's very performant. I think we are pretty close to state of the art, which is not that easy, and that's also where AI comes in, because I translated quite a bit from existing open source C++ ray tracers, and it worked surprisingly well. And I think in Julia the code is much more readable and extensible, which seems pretty novel to me, because ray tracers have been these huge monsters which are really hard to extend and work with. And I think now having them in Julia will make a big difference to actually have more people play around with it. Yeah, and another package is Hickory, which is basically the old trace.jl, which we renamed because trace is already registered. And this is actually implementing the more complex materials and lighting models based on RayCore, pretty much. And then the final piece of the puzzle is actual Marquee integration, which is happening in Trace Marquee, which is already pretty far. This is a Lego scene showing off animations, now with shadows and everything. This has been working before with Radeon Pro Render in Marquee, but now the Trace Marquee is far enough that this actually works. And this video was rendered in 12 seconds, which is really fast for ray tracing. I think the first version of Trace, before I optimized it, might have taken a couple of minutes for this, with less quality, I think. And another exciting thing that happened is the folks from Breeze contacted me that they're really excited about ray tracing because they needed to render their clothes. And I managed to very quickly integrate it with Hickory, also with the help of Claude Code, because I don't actually know these algorithms that well, but now it's relatively easy to just port these materials to Julia and then plug them into the existing ray tracing framework. And I think the results are really beautiful. This is just a very low resolution cloud, and it still looks already pretty nice. I also implemented some post-processing, which is pretty important for ray tracing because it's closer to photography, so you might want to change the exposure and things like that. And there are certain pre-processing models to remap the HDR images to the visible range. Yeah, and this is very exciting for me because it shows how that this actually works. And it's fast. This renders in 0.3 seconds, and it's not even on the GPU. And there's still an allocation bug in there. So I think this will render in... I had it working on the GPU a few weeks ago, but then it broke again after some refactors. But I think this kind of image will render in 0.01 seconds or so. So it's almost... I mean, it's already here, ready for interactive use, I think. And the ugly thing you see here while rotating, that's actually geomarquee. That's what you would get without the ray tracing, basically. So I think this is a pretty nice improvement for fidelity. Yes, now we are already at the throwback to JuliaEO 23. We started developing Tyler there, which I think was a really fun project, and it's still living, and people use it actually. One of the coolest visualization was from Alex at the Jet Propulsion Lab, who is working on tracking glaciers. And he made a really cool visualization with it, with real data of tracking a glacier. Yeah, so you can plot on top of it. It renders all kind of tile sources. And it also works in Bonitobook, hopefully. So here you go. I also tried to polish it a bit for this talk. I hope I improved the tile loading a bit, and like at the end of the week, we can make a nice release of Tyler, because it was a bit, yeah, not that many people worked on it in the last years. Although there was constant activity, I think, on the repository. What I did, I think 2 years ago, was Julia Hub actually asked me to implement 3D rendering in Tyler. So now you have like this cool 3D map with like elevation data. And we actually also added some other tile sources, and you can, if you have like data on the globe with 3D data, you can write your own plugin basically to load from there and display it and plug into this. Yeah, another project was AndyViewer that got started here. It supports loading any dimensional data array. I still have Yax array in here. That got lost somehow. But Yax array as well. It offers a simple YAML syntax, but also like a dict-based syntax to define what kind of data slices you want to map to a certain marquee visualization primitive. And then it creates like an interactive app out of this. It also has basically plugins, which are just, in the simplest form, it's just a marquee recipe basically, which you can then also address from the YAML syntax. Yeah, and this also works in Bonitobook, and you can put this on a web page or into any other Jupyter alternative or notebook, which is also thanks to Bonito here and WebGL Marquee. So I think this is pretty cool. The Air Center, I think, also published something like this, but I'm not sure if it's online. Okay, yeah, but this will be interesting, I think, to see that in production. Yes, and finally, a few words about using AI in Julia. First of all, I'm using MCP REPL, which is very important, because without the LM being able to actually run Julia code, it usually doesn't understand the code base as well, and might actually use outdated functions and stuff like that. But if it can just run code, it very quickly adapts to that. And I've had like some really nice success stories to just one-shot dashboards. You can even show it sometimes a picture and say, I really want to have this kind of dashboard, but with my data and my packages. And it sometimes works and sometimes doesn't, but usually gives you a good starting point. So I think right now is a good age to try out new languages and new tools, because it became so much simpler to get started. It's also great for translating from other languages to Julia. As I said, with the ray tracing, that was, I think otherwise without Claude Code, this could have been a one-year project or something like that. But because it has become so easy to go into existing open source projects and translate it to Julia, it becomes very easy to close gaps in the Julia ecosystem. And it's also really good at mundane inspection tasks, like telling it, run code warn type on any Julia function in my project and check for type instabilities, which are bad for performance. And then it will usually be able to fix them really quickly, and will do that for 100 functions without problem. Yeah, and like review codes or go through the documentation and make sure it still makes sense. Yeah, and this actually, I think, I've used it to improve the marquee documentation. It's still a PR, but will be merged pretty soon. And it also inspired me to structure the documentation better to be accessible from Julia as well, so that you can look up documentation and have like a starting point which explains how the marquee documentation works, which is obviously also good for humans. But I hope this will help much more to get people started. Yeah, and the missing gaps in the ecosystem have been quite clear for me and pretty problematic sometimes. For example, I've been wanting to have a GLTF loader for quite a long time. It's a relatively complex 3D model format, which allows you to, in one shot, basically load a whole 3D scene into your language. And that hasn't existed yet. And it's a pretty complex format. And I was able to implement it in half an hour, an importer for this. And that's how you get like fun 3D models like this into Marquee now. It's also not published yet, but this is also like one of the first prototypes of the new ray tracing framework to render more complex scenes. And that's already it. Thank you very much, and I'm happy to answer any questions.
Thank you. Okay. I'm very interested in the use of parallel computing for artificial intelligence. And since you are describing the advantages of Julia in doing artificial intelligence for this specific case, could you highlight a little, in short, I know you spent a few minutes talking about it, but what is the advantage of Julia in relation to other also languages that also can do parallel computing? And so, of course, people have been using them for AI. Thank you.
Yeah, that's a very good question. I should have highlighted this more in the talk. I think Julia is in a really good position there because complexity also matters for LLMs. The longer the code, the more difficult it is for the LLM to reason about it. So terseness actually improves the code output of LLMs. And Julia, there are a lot of plots for this, like Julia is really at the sweet spot of being terse and performant. And the other thing is to be able to just evaluate a function, run it, test it, and actually get the LLVM code from it, the GPU code from it, the type code from it. That's introspection you don't have in many other languages, which really helps the LLM to understand the function. So, yeah, I think, I had a lot of functions that weren't working well, and then it just looked at it with code typed, and then it found the problems with it, and then it suddenly understood the function much better. So I think that's a very big point. Yeah, and I mean, I don't know how it is in C++, but I find it hard to see the workflow of compiling your whole code base and then running something. It obviously works, but it feels much easier in Julia. Sure.
Awesome. And one thing I wanted to highlight is some of the features you've added, the color bars and things, I think are going to really maybe improve the how many people switch from plots to Mackie. So I think as a community here, we've always been very excited with Mackie and delighted about of the progress every year. So I think great work, and I was wondering if you had some sense of, at this point in time, where Maki is compared to the general use within the community in terms of plotting, compared to, say, plots and other things?
That's a very good question. I don't have a good sense of that. I only have a gut feeling, and my gut feeling is that for more complex projects, most people start to use Maki in the Julia ecosystem. There's a long tail of like very simple plotting tasks where most people avoid Maki because of the compilation times and that it's kind of heavy, and that it's missing like the UI to save plots and things like that. So I feel like people that very quickly run one script and do one simple plot that doesn't need to get tweaked usually don't use Maki as much. But it seems like everything I read online where people talk about plotting in Julia, it seems the conclusion is to use Maki. So that feels, yeah, like that's a very good progress there.
Great. And I guess I'll add that I'm going to try Bonito book soon.
Cool.
Yes, very impressive talk. So all this work you've been doing with the ray tracing, it looks a bit like it goes quite beyond what we normally consider plotting. Do you have any ideas or of applications that you wanted to dive into, or do you want to do more like a graphics interface? No, graphic, yeah. More animations, graphics, what kind of things?
Yeah, that's also a very good question, because I'm pretty excited about it, because I think this backend will open up a lot of possibilities, because it's written in Julia and modular. So there are certain kind of visualizations where people have been wanting to have callbacks for every pixel basically you render, or really have callbacks on the geometry of the visualization and things like that, and they need to be very high performance, which is now possible since it's all running inside Julia. And the other thing is, since it's kind of modular, I got quite a lot of feedback of people who want to use the ray tracing in completely different areas like simulations, which is really cool because they are also having really high performance demands, like simulating heat transfer on satellites, for example. And there are already users there that use that. So they use Raycore in their simulation. And this is really cool because they will also be working on the performance and things like that.
Yeah, and I have a question on AI. I absolutely agree with you that in the age of AI, a step to learning a new language becomes actually really like, there's not much of a barrier. Whenever I say like, hey, let's do this like bit of teaching in Julia, none of the students would ever complain. They just go to ChatGPT and like, how do I do this? And all the more senior academics say like, why do you introduce a new language? I'm like, it doesn't make a difference.
Yeah.
Does that actually mean that for, I think especially plotting libraries, I see more and more people interacting by literally just asking, prompting like, I want this, can you do this, and so on, that you would build Maki in a different way so that in the end you can either write your lines of code as you normally did, or you literally just talk to someone and say like, can you move the legend to the right? Can you do this? Can you do that? And it would basically just understand all the Maki stuff. Because I feel like especially plotting is something where you always like visually have an idea of what your plot is supposed to look like, but actually finding all the knobs of how to achieve that is tricky. And so maybe AI will change that drastically.
Definitely, that's a very good point. I'm thinking quite a bit about it. Because I've also been using this to create plots, And it's very funny because usually you don't watch, or I usually don't watch Marquee users, how they create their plots and what problems they run into. And when the AI is actually just doing it in front of my eyes, I'm seeing like, oh, it's getting actually stuck there because that seems to be a difficult to understand API. So I think our layouting system, for example, might need a rework because it stumbles upon this quite often. And I also stumble upon our layouting system. So I feel like this will be something basically, I mean, inspired by AI is a bit silly because people also run into this, but it definitely showed me that there is something we need to change to make it much easier to create plots in that area. And the whole moving the docs more to Julia and making them more explorable so that you have like an entry point and then you see what's possible and then you can dive into the documentation from Julia is also something that I'm prioritizing for LLMs to make it more easy for it to actually create dashboards with Marquee. So there's definitely things I'm thinking about. All right. Thank you. And of course, thank you, Martijn, for jumping in.
We're going to have a different talk now. Then we have coffee break, then expert hour. I would like to ask, without wanting to put you on the spot, Christoph, if during expert hour you'd like to discuss what we discussed today and that you presented the very last slide on your presentation.
Yes, I've been talking to some people and it seems like some things are already good.
Shall we discuss that then?
It's your turn now. Sorry? It's your turn now.
It's my turn now.
Okay, let me bring that. It's not the coffee break.
It's not a coffee break.
Okay.
It's my, I think. Let me just, what's happening here? Why can't, is it connecting?
Let me introduce you.
I don't want. Yes, please.
Now our next speaker is Tanya Dinis. She has over 20 years of experience as a clinical psychologist, cognitive behavioral and integrative psychotherapist, trainer, entrepreneur, and social activist in many causes, namely climate change. In 2020, she became one of the founders of ecopsi.org that focuses on the role of psychology as a tool to understand and deal with the impact of climate crisis on mental health and our individual and collective responses to it, aiming to raise awareness and promote better responses that are informed, adaptive, and sustainable to deal with the crisis on individual, organizational, and societal levels. I would like to welcome Tanya Dinis.
Thank you. Can you hear me? Okay. So, we're talking a little bit about how our minds process climate crisis, how it impacts it, and how we can build resilience around it. So I know this is a bit on the side to what this whole conference is about, but I think it's important for us to understand what happens around us and how we're impacted by it.
So I'm curious about what's your experience. Who's in constant contact with climate crisis data? No one? One? Maybe? So you do like the background structure, but you don't actually see like what's going on and like how it's running. So anyone ever been frustrated by people's lack of awareness on the topic?
Sorry, when you say climate crisis data, that means data that pertains to climate crisis?
Related to climate crisis. It can either be from the news, it can either be from your work, like if you're working on models and you see, well, you create the I've heard a lot of talks about creating models. I'm not sure if you're in contact with what it means and the implications. So, because that I think is the actually stressful part of it. So anyone's ever been confused with the gap between having information and understanding or action? Okay, a few more. Anyone experienced or witnessed someone burning out from it? Or from work in general? When I widen the scope to work in general, we have more hands up. Okay, the good news is whatever I'm going to say about climate anxiety and dealing with it applies to all sorts of anxiety. So you can still take that. So I think it's useful to have a context about how our mind processes climate crisis and to understand that it's a difficult problem for our minds. There's a lot of smart people in the room, so I'm sure you all enjoy engaging with challenges and problems, but there's a difference between engaging with something that's challenging and something that's scary. And climate crisis has a lot of layers. It's complex, it has many variables, there's long periods between cause and effect, so sometimes it's hard to understand how much it matters to take a certain step. It's continuous, so it means it's also tiring. Our minds get bored with something that's ongoing for too long. It has a strong emotional impact, so it's scary, it's overwhelming, and our brain doesn't like that. It allows for diffuse responsibility. It's hard to say exactly what, who, when, even though we have some ideas. So it's easy for people to back away from it with a sense of, I don't really have to do much about it. It creates cognitive dissonance in the sense that cognitive dissonance is when we deal with different information. Like, I know that, I'm going to use the example of smoking because I think that's the easiest one to understand. Like when our mind at the same time has the understanding and information that it's bad for us, that it's bad for health, that's indisputed, but at the same time, it still wants it. We have this with consuming, for instance, with traveling, with a number of things, and it's challenging. It has varying distance from impact. For some people, it's a reality happening now. They're exposed to it. For some of us, we hear about it in the news, we know it's a problem, but it's not impacting our life immediately. And it's something that we hear about from a sense of it requires change, and change is unavoidable. The issue is what's the direction, and change is actually quite a difficult thing for humans. I don't know how many of you have already tried to change habits or embrace something new, and the step between intention and actually making it happen, it's hard. Also, individuals respond differently to this in the sense that it depends on how much knowledge they have, what's their context, how much they're engaged, what are their internal coping mechanisms. Are they better with dealing with stress? Are they worse? How can they manage themselves? Their perception of agency and self-efficacy, which means how much do we feel that what we do matters, that it has an impact. And also our empathy to understand other people's perspectives and what they're experiencing and having that as a drive to act. So it's hard because we tend to think of ourselves, in a way, we tend to think of ourselves as rational creatures, and The thing we aren't really aware of a lot of times is that decision-making has a very significant emotional component. We hesitate with the cost of some of the decisions. Like, it's never hard to decide if it's all good things on the direction we want to go, so there's no choice there. But often we have to make choices about, to get this, I need to give up something else. And that's challenging. It's easier to hold positive information in our attention span, so reversely, it's more difficult when the information is negative. We try to protect ourselves. And humans tend to feel discomfort with what's unfamiliar, it's unpredictable, threatening, something that creates a sense of shame, like, oh, I should be doing more, but I can't, so might as well not think about it. And being confronted with information about climate crisis often triggers defense mechanisms. Denial, I think we all have a sense of what it is, like when people say, oh, it's not such a big deal, or some go to the extreme of saying, no, it's not happening. Some say that, oh, no, this isn't something that's actually human influenced, so there's nothing we can do about it. Exceptionalism is an interesting one for me, because it's when we say, yes, this is bad, yes, I shouldn't be doing that, like people shouldn't buy or shouldn't do certain things, but it's just me, so if it's just me, it doesn't matter. It doesn't make a difference. It's like it's pushing away responsibility. On a worse level for me is when, yes, climate crisis will have an impact, but I have enough money and resources to exempt myself from the consequences. I can buy myself a house somewhere safer, I can protect my people, my bubble, whatever else happens to the world, not my problem. Another thing we tend to do when dealing with difficult things, again, this applies to climate change, but this also applies to any conversation you have in relationships, in work environments, which is easier to blame. Like, I'm uncomfortable with the situation. It's easier to focus on who's to blame? Oh, it's not me, so someone's at fault. Those people are the ones who should be fixing it or being punished by it. And it's easier for our brains to think about that than it is to engage with, okay, let's think about how to deal with this and focus on a solution. Blaming has another problem, which is it enables aggression. Like, if we are blaming someone else, if we are putting distance between ourselves and other people, it's easier to say, to deny resources, to get angry at them, to attack in some contexts of political chaos. This is how we get there. And why do I bring this? Because we're all going to be required to change in some measure or another, but no one ever changes from a position of comfort. Comfort actually does the opposite. It makes us want to safe, keep, and preserve what we have. So understanding that discomfort is actually necessary for change and not being scared by it actually helps. And also to understand that this is an issue that's not about how intelligent we are. It's not about IQ, but about how we can put together the information and the intelligence with our emotional capacity to deal with it. And understanding that, what I said before, that some of our brain's functioning mechanisms, the defense mechanisms, work against us in this context, help us understand that working around it requires intentionality and resilience. So it's not something that's going to spontaneously happen. We have to choose to take a more difficult road. And hopefully understanding this, that it's not about people being good people or not being good people, but understanding that this is actually challenging, hopefully helps to increase the empathy for ourselves and our inconsistencies, because I'm sure everyone in this room has some experience of wanting to do something, but then not failing to do it, and then being a bit confused about it or not happy. And increasing empathy for others with different views, which reduces polarization and increases the possibility of mutual understanding and cooperation. Again, this is important for climate crisis, but if you think about it, this is important for anything you do in your daily lives, in whatever projects you're engaged in. And this is not a new topic, but it's been prioritized only recently, the topic of mental health and climate crisis. Actually, it's only been in 2022 that it's been mentioned for the first time by the Intergovernmental Panel on Climate Change report, that before used to just focus on physical health impacts. So people can be exposed to climate change in direct and indirect ways. Direct ways is when people experience extreme natural events, like heat waves, floods, vector-borne diseases, which increase the risk of immediate adverse response. Like people can respond with anxiety, depression, trauma, post-traumatic stress disorder, like when people really experience firsthand. I imagine that not many of us, if any, are in this space, but all of us are in the space of indirect impacts, either by the amplification of effects generated by climate change, like the economical costs, the increase in poverty, people who need to be displaced, and sometimes, and it impacts the people being displaced, but it also impacts the host areas receiving the social conflicts, food and water scarcity. Like there's a number of things that will create a higher sense of uncertainty and insecurity. And there's secondhand exposure. We hear it about the news, we hear it about social media. We all know the social media algorithms, which is they tend to present us with what we click the most. What we click the most tends to be the negative things because our brain loves the negative, because we've survived and evolved, because we were able to identify threats and avoid them, which is fine, except with news 24/7 and social media, we are exposed to a lot more information than the brain can handle. And so it increases like fear, it increases inadequate responses that don't really help deal with the problem. So I also wanted to share some of the groups that are particularly impacted. People with previous vulnerabilities, if they have mental health challenges before, like imagine being depressed and dealing with something like this. Being in impoverished communities, people living in disaster-prone areas, young people, which they are more impacted by climate crisis on their mental health because, one, they've never experienced the world without it. I remember a world where this wasn't such a big part of my future. Like, I mean, there was concern, but not a sense of impending doom. So, and also they have more time ahead to face the impacts. It hinders their dreams for the future. Like, how can I imagine a future if I don't know how the world is going to look like? They feel betrayed and abandoned and dismissed by the people in power and governments who they were expecting to protect them. And this is something that we need to be mindful of. Frontliners, which is climate activists, climate scientists, and that's why I was asking who's in direct contact with this, to understand like how many of you fit in this space. Journalists, policymakers, first responders, like firefighters, medical personnel, etc., because they get the first hit whenever something happens. Farmers, we don't tend to think of them, but they are directly impacted by weather changes, and we are impacted because if the weather impacts farming, it impacts food production, and we can all imagine why that's a problem. Indigenous peoples whose cultural inheritance and close connection to nature is a big part of their lives. So for those of you who like numbers, just a few highlights. In 2020, in a study by the American Psychologists Association, 68% adults said they had at least a little eco-anxiety or anxiety or worry about climate change and its effects. 48% young adults, 18 to 34, said they felt stress over climate change in their daily lives. In a sample of from 18 to 75 years old, 1 in 5 experiencing eco-anxiety, 1 in 4 feeling this anxiety interferes negatively with their daily functioning. And interestingly, going back to the kids, in a study involving children and youth, one of the questions was if they reported that climate change impacted their daily activities, like going to school, spending time with friends, like what they do generally. And I think it's interesting to notice a difference where you have 26% in UK, 31 in Finland, 35 in France, but then you have 74 in Philippines and India. And I think it's important to look at some of these numbers to give us pause that, okay, we are not all being affected the same way. And 75% worldwide thinks the future is frightening. Like, that's not the best way to grow up, I would say. So, dealing with climate crisis, being confronted with it, can have a number of mental health impacts. Anxiety disorders can be at many levels, but some physical signs to look out for. Tightness of chest, like shortness of breath, stomach issues, fatigue, headaches, fast heart rate. I mean, I think we've all experienced it to some extent. I mean, some of us coming up here and talking in front of an audience. But the problem is if it's ongoing, if it's something that lasts over time. Mentally and emotionally, some of the signs are intense worry, relentlessness, irritability, difficulty concentrating, a sense of impending doom, and trouble sleeping, often accompanied by behavioral avoidance of triggers. So again, what our brain doesn't like, it tries to avoid. So we kind of have to intentionally direct ourselves from it. And eco-anxiety is one of the most visible effects in terms of mental health. It's what we talk about the most. It's so far the most pervasive, like the most frequent identified. But what is it actually? So it's an anxiety that's in context related to climate change and environmental impacts. So it includes all these feelings that I mentioned before, plus feelings of helplessness, hopelessness, guilt, shame, sadness, anger about the future. And this can build up to a point where people just don't carry on with their daily lives or just do something completely different. So, but the thing about anxiety is, in this context, is a rational and constructive response to the seriousness of the problem. Like, it's not an illness in the sense of a dysfunction, it's just a natural response, the same way that anxiety itself is an important and useful emotional response. I like referring to this anxiety curve because it helps us to kind of to realize that we all experience it. Like, the only time we have zero anxiety is if we're sleeping. So from the time we awaken and start thinking about things, we start having like little moments of it. But actually, there's a level of anxiety that's useful. It's an adequate level of activation. Like, we care about what's happening. We pay attention. We are more engaged, more empathetic. Like, we move. We're driven to act instead of just passively sitting back. And actually, studies even say that our immune systems run better with a little bit of anxiety. The problem is, if we're exposed to a threat that's too high or too ongoing, we go from one side of the curve to the other, and then we fall into excessive activation, and then we start using maladaptive coping mechanisms like denial, no, this isn't so important, paralysis, which often we call procrastination, numbing, like distracting ourselves with cell phones and other things that cut us off from what we're feeling, but don't take away the effects. So, a question for you guys, like, can you tell when you're getting anxious, when you're getting stressed? Who realizes like when they're getting stressed? Like, who can realize like at the very beginning? Okay. So this matters because the earlier we understand it, the easier it is for us to manage it. So, but before we go into that, we're still going to go on the worst side of it, which is if we are exposed to anxiety for too long, we tend to burn out. Which, again, climate activists and scientists in this context are some of the more affected. But actually, people working in high-intensity projects also tend to burn out. So Some things to be on the lookout for if you're in that space where you've already you've worked a lot, you're really engaged, you think you can handle it, but you're starting to feel drained, overwhelmed. You start to feel more irritable, like you don't want to engage. You start to have more self-doubt. It's more difficult to concentrate. Performance starts to decrease. So if anyone experiences something like this, it's a really good time to take a break. Especially because once you get there, it takes a hell of a lot of time to recover from it. There are other potential impacts that I'm going to share just for context mostly, because I don't think you're going to deal with any of this, hopefully. Depressive symptoms if things get really serious. Post-traumatic stress, again, when people are exposed to severe circumstances. Loss of places and belonging and loss of identity. This picture here was actually taken after the fires in 2017 in Portugal. In Portugal, no one knew what Pedrógão Grande was. Most people didn't. It's like it's a land. But after the fires, we all knew about it. And the loss of places of belonging and identity is when everything is taken away from you, or when activities that used to be accessible to us when we were kids, they're no longer accessible because the climate conditions don't allow it. And the anticipation of future losses can also lead to higher competitiveness and aggression. And one that I really like to share whenever I'm talking about this, which is just the temperature rise in general, like the air temperature, in which we exist, is accompanied by a rise in aggressivity and interpersonal violence. It leads to higher irritability, reduction in attention span, and emotional regulation, and also in cognitive skills associated with nonviolent conflict resolution. Most of us never thought about this. It's not just whether there's a cyclone or there's a fire, just our everyday environment. There are studies that if it increases beyond 2 degrees, there's actually numbers that I chose not to bring because I don't want to stress you that much. But there's actually studies about what's the estimation in rise of violent crime if the temperature rises, regardless of whatever else is going on in the world. So this is just some extra motivation so that you do a really good job, so that the other people get information, so that we can do better with this. Just a quick share, jumping into what I see in my clinical practice. I see young adults questioning the point of studying or making other future plans, if there won't be a planet. Given teenagers are a bit all or nothing, so we can put it in a more amenable way. I have couples that argue about different views on family consumption patterns. How do we buy? What do we buy? Where do we go for holidays? Do we travel? Do we fly? Do we not fly? Do we go by train? Do we have children or not? Because do we increase the population? Is it responsible to bring kids into the world? There's a lot of very practical daily life effects of the immersion that we have with this issue. And then I have a specific group, which is climate activists, and then they have a whole other load of stress factors, which is, one, they're always exposed to the information. Two, often is local and international because there's solidarity networks, so often the ones I work are in cooperation with other people affected. The fact that it's mostly volunteer work, so it has challenges of itself in terms even in making their own livelihood, balancing this. And facing public criticism and lack of political dialogue, which sometimes some of you will face in your organizations, where you bring up information. Well, if you're in the very technical background, maybe you don't have to deal with it, but if you're on the product delivery end, not always is the information well received. So, everyone stressed yet? Really stressed? Not really? Doesn't apply? Well, this was just stressing you guys first and then kind of giving some ideas of how to step back from this. There are ways that we can use to counteract anxiety. It's important that we understand that anxiety is a threat versus safety kind of response. And anxiety exists in the space between the resources I think I have and the size of the challenge. But if we increase our sense of safety, we can close this gap a little bit. So and the more we close the gap, the more we reduce anxiety and the more we are able to continue. So sense of safety can be fed by taking action. Whenever we act, we feel more in control. We feel more with more agency and less vulnerable. A sense of competence, which we can get either by learning whatever we need in our own context, but also when we act, we have an effect. When we have an effect, it either works better or not, but it tends to increase our sense of competence. So this one's, and competence isn't about being the top of the class. Competence is about being able to act with an effect. Connection, collective engagement. We're social creatures, so connecting and working collectively really makes a difference for us. Seeking laughter and sense of humor. Funny, anything with humor, anything that's funny will help counterbalance anxiety. Immersion in nature. If you manage to get to a place where you don't see human construction, if you don't hear noise of traffic, our cortisol levels go down, they love it, serotonin goes up, our brain just loves being in nature. A sense of awe, like seeking things that are new, that you go like, wow. Either it's something in your fields, either it's something related to art, something amazing in nature, but whatever gives you this feeling of, whoa, this is amazing. And playfulness, being absolutely ridiculous, like doing silly things, either joking, bantering, exposing ourselves, like not in the sense of always being proper, but like just taking the chance of being funny. So, this might go without saying, but there's one that's mandatory, which is sleep. To have a system that's sustainable and resilient, we have to have regular cycles of effort and recovery. And often when we're diving in projects or when we're dealing with difficult topics, we don't do this. We just another night, an all-nighter, it doesn't make a difference. Well, it does. Sometimes we have to do it. I just want to kind of raise your attention and awareness that we shouldn't trivialize it. Some other ideas, self-regulation, like how we manage our emotions, which actually requires learning about emotions. And we can learn some stress coping skills. That would be a whole other workshop. And one thing that's very easy is regulating access, well, not so easy, but regulating access to information. When do we watch the news? When do we scroll on our phones? Not being exposed all the time makes a difference. Exercise, meditation, yoga, whatever works for you. Be mindful that anxiety raises our adrenaline levels, so one of the ways to disperse it is actually moving. So if you're really stressed, going out, walking is actually effective with our biology. Having hobbies. Anyone here is fan of Lego? Oh, I was hoping like 100% hand raise, but that just goes to my expectations. Journaling, gratitude lists, and I'll go back to that. Seeking professional help if needed. Hopefully, if you prepare, you don't need it. One thing I wanted to say about gratitude, it's one of those things that people react with, is like, wishy-washy gratitude, like what? But actually, super cheap, costs you zero. Like, there's no money going into it. Very little time, and actually on a neurobiological level, it helps regulate the sympathetic nervous system. And I have a little bit more data, but the point of gratitude is where anxiety and worry and fear focuses you on the threat, on what you lack to deal with it, gratitude, on the other hand, focuses our brain on the resources you have, the people you have around you, the things you're capable of doing, whatever resources you have, it focuses our attention on that. And it's important to understand that our brain goes to the negative on its own, because that's how we're designed. But with overexposure, it goes to unhealthy levels. So we need to kind of shepherd it back to reality. And gratitude is not those rosy glasses, everything's fine, nothing's going to happen. It's not that. It's just an inventory of what we actually have that will be useful to deal with whatever we have to deal in life. So I just left you some data about that. More recommended things: taking action individually, making choices that are consistent with the knowledge you have and your values. Little things in our life that we can do to be more consistent between what we believe is good for environment and for ourselves. Again, I reinforce the collective aspect a lot because it makes a real big difference. And it can be seeking groups who share values and beliefs to work together to go our goals and mutual support. And you may already have it in your organization. I think actually this conference, coming together, working together in common problems or helping each other in problems that they're not your own, is actually a very good example of that. Feeding also social groups, family, friends, because that helps regulate anxiety as well. Promoting flexibility, because there's never going to be one tool that's going to fit everything, but if we have a range of options on how to regulate ourselves, we can probably deal with most things. And I wanted you to keep this idea that these are not temporary measures. This is not something, oh, I do this when I'm in peak stress. No, some of these things are things you built into your lives, and so it makes life easier and it really improves mental health. On an organizational level, for those of you who kind of have that, that are in that space, sharing information to promote reframing and contextualization of climate information where in how it applies, workshops to capacitate in coping skills, which can be about this, about how to manage yourselves, favoring group settings to promote adaptation, empowerment, and well-being, an exam setting by leadership. If you have an organization that suggests workshops or suggests activities, but then in reality, the leaders don't do it and act as if that's something for the weaker, less people, it's much less likely that the rest of the organization will adopt. And one thing that's also important to keep in mind is that information alone does not bring about change or additional well-being. Like you hear me today, you do nothing of the things I've mentioned. Impact in your lives? Nothing. Using it can make a difference. Also, addressing the emotions and collective engagement is essential. Because again, I can't stress this enough. We seek connection, we seek belonging, we seek recognition. So community and collective engagement are really, really powerful tools to promote a sustainable system that reinforces itself and lasts over time. And I wanted to finish with a concept that that's very dear to my heart, which is the concept of radical hope, either in dealing with climate crisis or any challenges in our lives. Because one is a choice. We can choose to look at a problem from all the obstacles perspective, like all the things that can go wrong, everything that can fail, or we can look to it from a perspective of resources and what we can achieve and gain. It means believing that it can get better no matter what. Wherever we are, if we act, it can get better. And it's realistic in the sense that it's not about denying the challenges or the dangers or the urgency, but it keeps us focused on what can be done instead of what cannot, and therefore increases our chances of getting a more positive outcome. And I think we're probably all aligned that that's a desirable direction. It also makes for a much more pleasant journey. So, I, for one, would rather have a life where I can contribute and have goals and objectives and deal with challenges, and some days are gonna be days that we would just rather skip, press forward and move on. But that's part of how it is. But it can be better. like it can be better if we have a more hopeful perspective. So I will leave you some suggestions for, if you're curious, it will be in the presentation. The movie Don't Look Up can also be considered a horror movie, so if you're not into that, maybe you don't see it, don't watch it. Some references are relevant, and I will be around. So besides any questions that you may have today, like you can still approach me afterwards. That was a lot to get out in one breath. So, questions, anyone?
Sorry. So you told about how to keep mental health and to promote it and to sharing things and so on. And I have a question for you about what some people are saying about the future. Some people are saying that with the artificial intelligence and with all the machines that we can build with it, we can give more lazy time to people. So some people will not have even the need to work. Do you think that working is a way of preserving mental health, or someone that doesn't work at all and it has just fun is less healthy?
So our base needs are self-actualization, belonging, connection, recognition. So humans are always going to need to have things to do where they feel they can evolve, where they feel they can master something, that they can invent, that they are recognized as particularly good at something. So how this exists doesn't have to be in work the way we see it today. It can be in art, it can be in a number of, it can be in any activity. But if we do what other, like already some political experiences have tried this, okay, let's get everyone on the same level, let's make it democratic and equal for all, that's never gonna work. Like one thing is to have equal access to basic things like housing, health, food, safety, etc. Okay, that's common ground for everyone. But we all need something that we feel special about, that we feel engaged with. And if it's a system that doesn't create space for this, okay, we have this given, and there's the also the aspect of like the minimum universal income, I think, where it's also along this line of how do we make this happen. But we're still going to need to have activities. So we can't, there's a thing that's really important to understand, which is nature can't stand the void. So if we take away something, we have to always replace it with something else. If it's mental health and it's unhealthy coping mechanisms, we can't just say don't do this. We have to do this instead. Look to this other thing. So I have no idea what the future will bring. I have very wide perspectives. Like I think it can go very well or very challenging. But I think we're all going to need something for us to feel that we're thriving. And we're always going to need humans. So how we are going to envision a society where all this comes together, your guess is as good as mine. I don't know if this answers the question. Anyone?
I very much resonated with your comments around sleep. So I think it was one of the best decisions for my own PhD. I basically never put an alarm clock in the morning, and it really calmed me down. I think if my supervisor had asked me for, like, I don't know, regular meetings at 8 or 9 in the morning, I would probably have gone out of the PhD in a very different shape. And so I think that also definitely reflects back to how we work, right? So like for my own students now, I would never schedule or ask them to schedule a meeting early in the morning because I don't know what their sleep patterns are. And I want them to be as flexible around this as possible. And so try to schedule everything between like Tuesday and Thursday around noontime is kind of one of the things that I try at least, and obviously always ask for like what the people you're working with, what they need. Because I mean, there's many implications, and I think we all have to be very aware of them when we, in whatever we do, and especially given that we're working with climate data, where some people may deal with the implications of the data very differently than others.
Yeah, and sleep is definitely paramount, and we live in a society where we kind of adopted this culture of toughening it out, like managing on 3 hours sleep, all-nighters, like as if that would make us some sort of heroes of resistance. The problem is we're like materials, we have breaking points. And the problem with also not sleeping is that we lose the ability to understand how inefficient we are becoming. And one of the things that I think people need to understand about mental health is our entire society, our entire functioning relies on one organ in our heads. Like we have one thing in ourselves, like which is our decision-making machine, our understanding of the world machine, and we sometimes treat it as if it didn't need maintenance. Like, does anyone go home and leaves the engine of the car running all night and then thinks it's okay to pick up again the next morning? Like, we have this understanding for other things, but for ourselves, we often forget that we need recovery. And if you work with high-performing, like athletes, for instance, the first thing the first thing is rest. Like there's sometimes scandals on TV that soccer players were not in bed by 10 because they need to sleep or they will not perform at their highest level. And this is true physically, but it's also true mentally. The more tired we are, the less effective we are. And sometimes we have this period where there's like the deadline, there's something where we can't really work around, like the consequences are too big. But it needs to be the exception. We can't have systems built around people running at 150% because we're going to burn out if that's how it is. Any?
Yeah, thank you very much for this. I guess I have a question about how technology makes everything worse, in the sense that over my lifetime, I've seen the emergence of many technologies that were supposed to optimize me to a point, right? I have this remote control to my brain in my pocket. I have AI that is now pretending to do your job for me, and will lead me to whatever the design of the concept of the AI wants me to go. So I'm wondering how you, I'm assuming that you advise people to turn off notifications on their phone, for example, that's something that's bad for us. I'm wondering what you think specifically about this notion that AI will make us have more free time, when clearly that's just a corporate lie. And specifically the use of AI, large language models, as therapeutic tools for kids.
The use of AI?
As psychotherapists. Sorry, I'm not saying this right, but people who look at it as a way to go through therapy without having to see a human. Is that something that, in the context of this discussion, maybe should be emphasized a bit more? I don't know.
The thing is, AI is not a person. In terms of information and content, in a lot of health-related decisions, you actually have, there was a number of things in your question, but But in this last aspect, there's a lot of things where AI can actually even decide more accurately in theory. The thing is, for instance, one of the things that we know in therapy is that about 50% of the success in therapy is the relationship itself, is the connection with another human in a space of safety and trust. You can't fully replicate that with AI. As much as some people will dive into it, but when someone dives too much into it, often means that they're crossing the boundary between reality and fantasy. And it's wonderful to live in fantasy, and I think that's going to be the challenge. Like, how much are we going to allow ourselves to live in fantasies that in the end will tell us what we want to hear, or if we are willing to live in real worlds where people can be annoying and frustrating, but they can be rewarding in ways that I really don't believe, but again, early days, that AI can be. About technology in general, I don't know if you want to hear my opinion. But with any technology, what happens is we're toddlers with guns. And for those of you who don't know what toddlers is, toddlers like 2-year-old kids crawling. We're toddlers with guns. We create and we use it before we fully understand it. That's how we got to climate crisis. We had this amazing breakthrough in the industrial era, and we used it, and we felt comfortable, and we felt that we were gaining and gaining and gaining. We were so happy, like Western world. This isn't transversal. And then we realized, oh, there's something we didn't realize was a side effect. But also we couldn't, because it was the first time it was happening. Same thing with cell phones, or social media. It's not, the problem with technology is when we don't know how to handle it, it handles us. And there's a part that, again, may not be very, again, this is also more personal than necessarily the psychology side of it, but we have to understand that we're not all thinking about each other's best interests. Sometimes profit is an interest in itself that goes against what's good for humans. When you have social media with algorithms that we know will deteriorate the mental health of young kids who cannot defend themselves, of adults that are less capable of living their lives because they're so involved in it, we have the knowledge, but it's way more profitable because scary things keep us engaged. Engaged things means we're in contact with more ads. Ads mean someone sells. I think we need to understand all the variables in the equation, and again, it's a big, big problem. So if everyone does their little bit, in our own space already helps. But that's part of the challenge and why these issues are so complex. There's so many layers, and it's important to understand that we're not all rowing in the same direction. I don't know if that's going to be possible. So technology, so bottom line is we need to look at technology as a tool. What can it do for us, not necessarily what it does, and kind of protect ourselves from what it does to us when it's not something that is to our benefit. Does that make sense?
Thank you very much. We need to go to the coffee break.
It may have been slightly less than half an hour, slightly more than half an hour.
You are, but it's okay. So if you are online, this is the end of the day for today. If you're here after coffee break, we'll meet again in 30 minutes for the expert hour. And if you're online, I'll see you tomorrow again at 9 a.m. tomorrow.